Okay, we have vectors P, Q and R. We're told that BCDE is a parallelogram and ABE is an equilateral triangle. The magnitude of P is 3. Because this is an equilateral triangle, the magnitude of Q must also be 3. We're told the angle ABC is 90 degrees. First thing we're asked to evaluate is P dot Q plus R. So we'll expand it out, and this is going to be equal to P dot Q plus P dot R. Now the dot product is equal to the magnitude of P times the magnitude of Q times the cos of the angle in between. So for P dot Q, the magnitude of P is 3. The magnitude of Q is also 3. And the angle in between them, well, this is P and this is Q. This is an equilateral triangle, so the angle in between them is 60 degrees. And we should know from our exact value triangles that the cos of 60 is a half. So P dot Q, therefore, is going to be equal to 9 over 2. But we want P dot Q plus P dot R. P dot R, again, we'll look at our diagram. This is P, and this is R. This is a parallelogram, so if AD represents R, so does BC. So P dot R, there's a right angle there. If they're at right angles, their dot product 0. So this whole expression is equal to 9 over 2. Okay, B, next we're asked to express EC in terms of PQ and R. So this is just an alternative journey. So EC, we're going from here to here, but we need to go via a route that includes our vectors. So I'm going to choose to go minus Q plus P plus R. And I'll just make that P plus R minus Q, so it's nicer. And then we are given an expression AE dot AC equals 9 root 3 minus 9 over 2, and we're asked to find the magnitude of R. Now, this part is not entirely obvious looking at this, and people may have worked away doing your dot product with these. Because we've been asked to find EC in terms of PQ and R, what we might want to do is also find AE in terms of PQ and R. AE is just equal to Q. So this dot product here, the left-hand side, is actually equal to Q dot EC was P plus R minus Q. So that is Q dot P plus Q dot R minus Q dot Q. Q dot P is the same as P dot Q, which we've already worked out to be 9 over 2. Q dot R. Now, Q and R at the moment, this angle here, both, remember both vectors should really be pointing away from the angle in between. So what I'm going to have to do is shift Q up and put it over here. So if I draw in Q here, now I can get the angle in between them. Now this angle here is 150. This is 60, that's 60, that's 30, because that's 90 degrees. Because this is a parallelogram, these opposite angles are both going to be 30, and this other one must be 150. And this is 60, which is 210. That leaves us another 150 here. So this is 150. If I shift this line up, the angle that we're now actually talking about is 30 degrees. So Q dot R is going to be magnitude of Q, which is 3, times the magnitude of R, which we don't know, times the cos of 30 degrees. And from our exact value triangles, we can see that's root 3 over 2. And minus Q dot Q, which is 9. So let's just rearrange this slightly, tidy it up a bit. So 3 times the magnitude of R times root 3 over 2. Well, minus 9 plus 9 over 2 is minus 18 over 2, so that's minus 9 over 2 altogether. Now let's bring the right hand side back in. Okay, so now we've got 3 times magnitude of R times root 3 over 2 minus 9 over 2 is equal to, we brought the right hand side back in, 9 root 3 minus 9 over 2. I'm just going to rearrange and solve for R. So we're going to add 9 over 2 to both sides, so then we end up with 3 root 3 over 2 times the magnitude of R equals 9 root 3. Then we're going to multiply both sides by 2 and divide by 3 root 3. 2 times 9 root 3 over 3 root 3. 18 over 3, which is 6. Therefore the magnitude of R is 6. Hope that's helpful.